Hi everyone, welcome to these Python tutorials where we are focusing a bit on image processing related tasks. Now we have been discussing about deep learning related terminology and we'll eventually get to actual deep learning related tasks, whether it is regression or binary classification, multi-class classification, semantic segmentation. We'll get there in the next few videos. But let's finish this series off about talking about deep learning terminology by quickly understanding what ROC curves mean and what is AUC. And this can be very useful in binary segmentation. So let's jump in to see exactly what these mean. But first, let's look at binary classification. Again, we'll get to this in the next couple of videos, but when you put together a model for binary classification, the final layer that's going to provide you with an answer is using sigmoid activation function. And I hope you watched the video about activation functions. If so, you know right away that sigmoid activation function gives you a probability between 0 to 1, right? So sigmoid activation outputs probabilities between 0 to 1. Now, we set a threshold to convert that into a classification. So if your classification is this a malarial infected cell or a healthy cell or uninfected cell, right? If the probability is 0.8, then we say, okay, anything above 0.5, call this something, right? So this is how we convert a probability into a classification. So here is an example. This is your sigmoid curve. And we say, okay, if the value equals to 1, that's infected. And if the value equals to 0, that's uninfected. Okay. And on the x-axis, you have some value, whatever that feature value is, for example, right? I mean, whatever that output value is. So if that output value is, let's say, is 0.3, right? If that's 0.3. If our threshold is at 0.5, we say that, okay, this is uninfected. It's not necessary that the threshold shall be at 0.5 exactly at the halfway point. It completely depends upon the problem. If your problem defines you to be more accurate when it comes to infected, for example, in this case, then you may as well move the threshold to be 0.9, saying that, hey, I want above 90% confidence for me to call that to be infected. Otherwise, I'm going to call that uninfected, right? So the exact threshold where you set this completely depends upon your application itself. But I hope you understand that this is what sigmoid activation is giving you, which is a probability, and we are setting a threshold to convert that into a classification. Now, why are we talking about this in the context of ROC? Because ROC can help you figure out what that ideal threshold needs to be based on your testing data, based on how the model is performing on your testing data. If that's not clear, let's go to the next slide to understand confusion matrix. We have used this many times, and this is probably the most intuitive way of representing your output. So let's say we have a handful of test data, test images in this case, of both infected, uninfected, and we are testing our model, right? Validation is always important. So we are basically validating our model by sending all this data and classifying it. So let's say this is how it's classified. So if it's uninfected and it is labeled as uninfected, then it's a good thing. Then we say that's true positive. This is a binary classification. So you have the other one, right? So the other class here is infected. If it is infected, and if our model truly classify that as infected, then that's a true negative. So true positive, true negative is good. False positive and false negative is bad. That is where I have an infected one, but it is predicted as uninfected, right? Or I have uninfected where it's predicted as infected. So our goal is to minimize these two numbers and maximize the true positives and true negatives. That's when we get the best classification. So I hope confusion matrix makes sense. Again, this is only a binary case, so we can focus on understanding this in an easy way. Now let's look at ROC curves. Okay, ROC stands for receiver operating characteristic. It comes from statistics background, so that's why it has a non-intuitive name, I should say. Now, what is an ideal case? If I go back here, ideally I would have 0 false positives and 100% true positives. So if that's the case, ROC curve is basically a plot of false positives on x-axis and true positive rate on the y-axis. Okay, we are plotting the false positive versus true positive right there. That's what ROC curve is. So ideally, if our model is doing a perfect job, then we should see 0 false positive and 1 true positive. So if you look at this pink line here, this represents ideal model, the best model. So ROC curves can be actually used to compare different models. For example, if you have like 3, 4, 5 different models, whether they are deep learning models, you can actually put together something that has, let's say, one layer, one hidden layer, and then you may have 2 hidden layers and dropout and so on. So you come up with a few of these models and then literally plot out your ROC curves to see which one has the best one, meaning which one is closer to the top left. So in this example, blue is better than orange, and orange is better than green, and red is basically a random. If you randomly pick an image and assign to a class, it would be the red line. Okay, and we'll understand this in a minute. But number one, compare various models. And it's not just deep learning. If you have random forest, if you have gradient boosting and support vector machines, linear regression, go ahead and perform your binary classifications. Well, not linear regression, but the other classifiers, and plot it. Plot your ROC curve to see which one is giving you the best. So that's one use. But let's go ahead and try to understand this a bit better. So now let's go and plot our probability on x-axis and the distribution on the y. And if you look at this, this is true positive and this is true negative. In this example, 0.5 is an amazing threshold, right? Because if I put my threshold here, I can clearly separate true positives and true negatives, 100% accuracy. So there is a 100% chance that the model will be able to distinguish between the positive class and the negative class. That's what this is saying. And we already saw how the plot looks like for this, right? I mean, it's this red line right there. This is a perfect model. That's not, in reality, that's not how it works, right? I mean, in reality, you have some sort of an overlap. You will have some false positives and false negatives. We just saw that in our confusion matrix earlier. And then you have true positives and true negatives. And if you plot this, then you would actually get, for varying thresholds, okay? Then on x-axis, again, false positive, y-axis, true positive rate. Then it's not perfect, but it's not bad, right? I mean, it looks, this is the curve that is giving you, I mean, that represents your ROC. And by the way, one thing I forgot to mention, if you look at the area underneath this curve, for example, what is the area? X goes from 0 to 1, Y goes from 0 to 1, representing 100%, okay? 0 to 1, 0 to 1. So the area of this square is 1. So if your area underneath the curve equal to 1, that means you have an amazing, excellent model. There is 100% chance that the model will be able to distinguish these two classes. If your area underneath the curve is less than 1, it will be, like in this case, 0.8, that means 80% chance that the model will be able to distinguish between these two. Okay, now let's make this a bit worse, meaning both are overlapping. I cannot distinguish. There is no threshold. By the way, if my threshold is down here, my threshold can be up here, my threshold can be up here. This is just the curve for my model. Now I have to pick a threshold that gives me the best separation between the false positive and true positive. In this case, the threshold is at 0.5, which is probably somewhere around here. Okay, again, I'll show you another graph which may make a bit more sense in a second. Okay, here, it doesn't matter what threshold you pick. It doesn't matter what threshold you pick. It's not going to give you any better than 50-50 chance. That's what this is basically saying. It's saying, okay, you pick any of these thresholds. It doesn't matter. You cannot distinguish between positive and negative classes better than random chance. So this is, again, look at the area underneath this. This is a triangle. Area of this is half times your base times height, right? Which is 0.5. So there is a 50-50 chance that you get this positives and negatives. That's what that indicates. And this is a rare, if not a scenario that may never occur. In this case, we are wrongly classifying the classes. So you may have made a mistake if this is happening. Okay, typically you won't see this. Here, instead of the blue, true positives to be on the right hand side and true negatives to be on the left hand side, they're swapped. and your curve now is on the other side. Typically, the ROC curve should be on the positive side. It should never come down to the negative side with respect to the random chance. If this happens, go back and check something. You may have made some sort of a mistake. Okay, now how is this useful? In reality, especially for binary, like I already mentioned, you can actually use ROC curves to compare various models. Like we have seen here, to compare, is this random forest, is this support vector machines, and if there is something else that is deep learning, you can find the best model for your problem. The other way that we can use, which we'll use in the next upcoming tutorials when we do binary classification, is to find out what is the best threshold for this problem. Okay, so when you plot this ROC curve, the obviously we are trying to balance the false positive versus true positive. We don't want a lot of false positives. At the same time, we want to maximize the true positive. And the point where that happens is the point that's closest to the top left, right here, right? The top left is the perfect, and anything that's closest to that is the best threshold that's going to give us that good separation. And there is an easy way to find out. Again, once we get to the code in a couple of tutorials, we'll look at that. But for now, I just want to make sure you understand first of all, what ROC is, okay, and how it can be used, again, to compare models and also to find out the optimal threshold for a given binary problem. And AUC, area underneath the curve, is basically as it says, the area underneath the ROC curve. In this case, it's 50% in this case, which is more representing the real life situation. This is 80%. Okay, so we'll see what we get when we get to our binary classification challenge. But I hope for now, you're okay in terms of the concept of ROC. Again, once we get to our code, it makes more sense. So I hope, again, you found this tutorial to be useful. Go ahead and subscribe to this channel, and stay tuned for the upcoming tutorials. Thank you.